In this video, we will learn how to do coupling analysis on board file to analyze the coupling between aggressor and victim nets and their coupling coefficients. So let's get started. To open the board file, we'll go to File, Open. Just locate the file where you have saved it and double click on it. You can download the same file from the link given in the description. Once the file is open, make sure you have opened the analysis workflow. If in your case it is not opened there, you can go to Analyze and open Workflow Manager. After opening the Workflow Manager, you have to select Coupling Workflow from the drop-down menu and click on Select Nets link. Once you have opened the next selection window, from the View menu, you have to select Hierarchical View. Now here we are going to run the coupling analysis on all the data buses. To do that, I'm just going to select all the data buses. You have to select all the data buses and move it toward the right side of the window. Once all the data buses are moved to the selected nets, we'll click over Apply and OK. In the next step, we are going to run the analysis. To do that, we have to click over Start Analysis link. Once the simulation is done, which you can verify by green tick next to Start Analysis link, we are ready to see the simulation results. To see all the simulation results, you have to either click on View Coupling Tables or View Coupling Visions. First we'll click on View Coupling Tables, and here we'll get two tables. One is summary table of all the violations and their detailed tables. Before selecting any violation from the table, I just want to sort these tables in the form of maximum coupling coefficients. To do that, you have to just double click here, and as you can see, the maximum coupling coefficient is 16.9 here. You can also sort these tables in the form of maximum lengths, which you can find it here. Alright. Now to view the detailed table for coupling between data bus 5 and data bus 16, we have to just select it. And here we go. Data bus 5 is coupling between so many buses like 7, 6, 17, 16, 20. Now to view these violations in your board file, we have to just double click over it. Here we go. Now we are going to highlight the nets. From here, I'm just going to click on All Off first, then select the nets. Go to the simulation table. I'll just zoom in. And from here, we have to select data bus 5. So this is our data bus 5. I'll hold the control key and select data bus 7. So as you can see in this section, these two buses are running parallel to each other and almost overlapping. Due to this, there is the coupling between those, which can cause false triggering. Similarly, you can look for other violations from the table. So this is one way to visualize the violations in your design files. There is another way to do that. We have to click over View Coupling Visions, and it will mark all the tracks which are overlapping or coupling with other tracks. So as you can see, this is data bus 31, which is overlapping with data bus 17. So it is marked it with red marker because of its maximum coupling coefficient. So this is all net based analysis. There is another analysis which can perform, and that is directed group analysis. Directed group analysis will run coupling analysis on all the nets which are connecting two components. So in this case, we are going to run this directed group analysis for XU2 and U7, which is our DIMM module connector and FPGA controller. To do that, firstly, I'm just going to close this simulation table. Now in the next step, I'm just going to select all the directed groups. To do that, here we have to pick start component and end component. In our case, start component will be U7, select U7, and end component will be XU2. Once it is done, we'll just uncheck differential and point-to-point analysis. We are going for single-ended and multi-drop analysis and click on Create button. Once directed group are created, we'll click over Apply and OK. After selecting the directed group, we are ready to go for Start Analysis. To do that, you have to click over Start Analysis link from the workflow. Once the analysis is done, which you can verify by green tick next to Analysis link, we're going to change the view mode from net based to directed group and click over View Coupling Plots. Further on this, we are going to see the violations for selected data buses. So I'm just going to put a filter here and click over Restore Nets Filtered on the plot. So as you can see, all the red markers are the length of the tracks where we have maximum coupling between aggressor net and victim nets. If you'll hover your cursor there, you'll get all the information related to violation. And if I'll double click here, it will take us to the design where we have this violation. As I've told you, you can simply select the nets and you can verify where data bus 18 is coupling with the aggressor net. Similarly, you can click over View Coupling Visions option and it will give us the visual representation of coupling between aggressor and victim nets. Let's say I want to check for this one. So I'll go there and double click and it will highlight the part. So this was the expanded part for all the selected data buses from this table. Similarly, you can click over Scattered or Collapsed View and it will plot between coupling coefficient and track lengths. By double clicking over, or you can hover the cursor, you can simply locate the violation. Alright, so this is the part which I have selected from here. Similarly, you can find all the violations which are marked here with red colors. So in the next step, we are just going to close this plot and save the project. For more tutorials, visit us at resources.emaeda.com and don't forget to like and subscribe our YouTube channel.